So Astronix Research is building the world's fastest, most accurate, and lowest power ADCs. We're using a microcolumn electron gun array rather than transistors to do the bulk of the work. So let's look for a second at why we're doing this. We're going to compete in this ADC space, which is about $4 billion at the high end. ADCs are in literally everything from your washing machine to your kids' radio-controlled cars. But at the high end, for devices that run $100,000 plus each, they're in imaging systems, military radars, satellite communications, things like naval radars. And those are the high-end markets that we're targeting. Margins are very high at this end of the market, 80% or more. The total analog market, which we'll eventually compete in, is $32 billion 2009 and growing pretty rapidly. So why do you need these high-speed ADCs? What's wrong with what you've got now? Well, a lot of conventional technologies, technologies that people expect to happen, simply cannot be done currently without higher speed ADCs, more accuracy and higher speed with lower power. If you're Alcatel and Lucent and you want to build 100G or 400G photonic networks, just about a couple months ago, the very first ADC that could maybe do what you need to have done at the lowest end of that was announced by Hitachi. Hasn't yet been built, only simulated, and that's the very first one. Big, bulky unit. You need much, much better ADCs. If you're Cisco and you want multi-stream HD home networking while you still got your internet running and you got your movies coming, you need much better ADCs. If you're ONR or the Air Force Labs and you want to build really large, high-performance, integrated phased array antennas, you want radar coming out of one portion of them, and you want to be able to handle all of your RF comms from the same antenna set, and you want the ADCs and the amplifiers all integrated in a mass-produced component, there's nothing out there. You've got to have a new solution that's mass-producible. So what are we doing? ADCs with 10 times the performance of the current technologies, ultra-low noise amplifiers with integrated true time delay functions, for those of you who are familiar with phased arrays, very, very high throughput multi-port switches. All of these each one of these accesses multi-billion-dollar markets. So how do you do this? Well, first off, what you do is you drill really small, very high aspect ratio holes in silicon, and you do millions and millions of them at one time. Not with a FIB machine, one hole every 10 minutes. We're talking about millions at once. You're basically building CRT tubes, just like your Sony TV that's probably in the basement now that you got your flat screen. At least mine is. Except you're taking these tubes and you're building them with a density of 10 million guns per square centimeter. And if you can do that, if you can drill these deep high aspect ratio holes, put the electron emitters down at the bottom of them, get those kinds of gun densities, then you can build very, very high performance devices for analog, for RF functionality. You can provide the world's very first high throughput E-beam lithography devices. You can build mass spectrometers on a chip. They have impacts on battery technologies. We're licensing the process for all those things. We're focusing on ADCs, multi-billion-dollar market. Where are we going to do it? Well, we're going to build on a fabless business plan with direct sales to a very small number of early customers, primarily government and defense contractors, with a few commercial aspects like we've talked about. The manufacturing is all going to be done at CNF in Cornell or at IBM. We're going to do some tests in QA in the Front Range in Colorado and license all the tech out. So the management team is a good group of guys. I've worked with them for over 15 years in various businesses. I'm on my third startup. It's a very, very good group of individuals, and we have an extremely strong advisory board that includes a couple of people who I would be very happy to step into the CEO spot in a few years as we're growing. People who were heads of US operations for major semiconductor companies. The business is actually good. The financials are good. We'll do around $1 million within the first year after this funding round. We'll grow that to 17 shortly after, and the big growth up into the half a billion dollar range happens between year 4 and 5. The margins are extremely good. Our individual device cost or pricing is right around $100,000 for the early devices per chip. That is what people are getting now for devices with less capability than we'll provide. Our production costs are around $150 per in small quantities. So the average sale, year 1 and 2 is about $250K to large defense customers. Year 3 and 4, as additional devices roll out, will bump that average sale up to about $1 million, and it should grow from there pretty substantially. So we're never talking about huge, broad customer groups serviced by large sales organizations. Small, very focused, fabless business. We're looking for $500,000 in seed this round. That's at a $4 million valuation, 11.1%. We'll be looking, depending on the ADC business, for another $2 to $3 million in an A round next year. Exits from analog companies are very good. For the last 10 years, the average exit has been at 8x for an analog company versus 4x for digital companies. So, taken away from this, it's a MEMS electron gun. This is a non-transistorized approach to high-end analog. Thanks. It's an untapped market, and it's a very solid, reliable team. Thanks very much. We look forward to seeing you at 412. Thank you.